Welcome to our second lesson on the atmosphere. This lesson will have a specific focus on the ozone layer. Before we begin, let's take a look at where we're going to go. First, we will briefly review the importance of the atmosphere from the previous video. Then we will have a look into detail at the ozone layer, ozone depletion, and ways to reduce depletion of the ozone layer. Let us dive into the review of the atmosphere. As we discussed in the previous video, the atmosphere provides us with oxygen to breathe, carbon dioxide for plants to use in photosynthesis, and it contains water vapor that is a water source for the water cycle. On top of that, it moves air from the poles to the equator as wind and back to regulate the temperature of the Earth so that life can exist. One of the most important functions of the atmosphere is that it shields us from harm in the form of absorbing harmful UV rays and burning up meteorites. Permanent gases remain constant in their percentage, such as oxygen and nitrogen. Variable gases change in percentage from time to time, like water vapor and carbon dioxide. Liquids exist in the form of water droplets in the clouds and rain, and solids like condensation nuclei are made up of dust, smoke, or ash. If we look at a very brief overview of the layers of the atmosphere, we can see that the exosphere is the very outer limit of the thermosphere, followed by the ionosphere in the thermosphere that is very, very hot. The mesosphere is quite cold, and the mesopause is characterized as being very thick. The stratosphere houses the ozone layer, and the troposphere is where all life exists. In between each layer is a pause layer. If you want more details on the importance of the atmosphere and the layers, have a look at the previous video in the series. Now, for the focus of this video, let's look at the location and the function of the ozone layer. The ozone is represented by 3 oxygen molecules. It is found in very high concentrations, between 15 kilometers and 55 kilometers in altitude. The stratosphere contains approximately 90% of the ozone layer, and the other 10% of the ozone layer is located at the very upper layers of the troposphere. Here is a diagram that shows you where the ozone layer sits in relation to the troposphere and the stratosphere. The ozone has the potential to protect and harm life on Earth. This depends on how high up the life is found. We already know that the atmosphere filters out harmful UV rays, but this process is supported by the ozone layer. When the ozone molecules absorb UV, the UV rays split into an oxygen molecule, and they create more ozone molecules. As this process occurs, it heats the stratosphere, which increases the temperature because the UV is converted into heat. But unfortunately, the ozone is suffering from depletion, which essentially means that the ozone is diminishing in quantity and size. But why is this happening? A pollutant called chlorofluorocarbons move from the troposphere into the stratosphere and affect the ozone layer. We call chlorofluorocarbons in short CFCs, and they were first manufactured in the 1930s. CFCs are used in refrigeration, aerosols, and the manufacturing of polystyrene. This diagram shows the different ways in which CFCs and pollutants are released into the atmosphere. Greenhouse gases, fossil fuels, petrol and oil cars, as well as deforestation contribute to ozone depletion. The sun's rays are then reflected and absorbed by the atmosphere. The sun's rays are also absorbed by greenhouse gases and the Earth. Additionally, terrestrial radiation escapes from Earth into the atmosphere and heats it. But how does this deplete the ozone? What happens is that the UV rays cause the CFCs to break down. Here, the CFCs are broken down into chlorine atoms that attach to the oxygen atoms and cause the ozone to break down. This prevents the ozone from reforming and therefore causes the ozone to lose its protective abilities. Interestingly, one chlorine atom can destroy thousands of ozone molecules. So when more ozone is broken down than is reformed, that is said to be ozone depletion. So how do we measure ozone depletion? Well, we can use a technique called remote sensing, and this is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, like using a satellite. The concentration of ozone is measured in Dobson units, and the average concentration of the ozone in the atmosphere is about 300 Dobson units. The hole in the ozone is said to be whenever the concentration drops below 220 Dobson units. Since the ozone depletes, what effects does this have on the Earth? Some things to remember are that a 1% reduction in ozone results in a 2% increase in UV rays reaching Earth, and UV rays damage and destroy living tissue. Unfortunately, as the ozone depletes, so does the ability to protect from UV rays, which can increase the risk of skin cancer and eye cataracts. Other effects are the lowering of the immune system and a bloom of malaria. On the environment, we can see weather patterns changing and rising surface temperatures. Additionally, there is a change in the life cycle of plants, and it is possible for microscopic organisms to die. Both of these disrupt the food chain, which have a knock-on effect. But there is always hope. So how do we reduce ozone depletion? We can use ozone-friendly products and regularly check your car from air conditioner leaks. And if you're a technician or know a technician, repair your fridges and your air conditioners so that the CFCs are not released into the atmosphere. Be cautious when you fly on planes as they contribute to high emissions that reduce oxygen. The production of CFCs and chemicals that knowingly break down the ozone should be reduced and eliminated. Finally, plant more trees. But before we end off, let us have a look at what the ozone looks like now. Here, you can see a video from NASA that shows the ozone changes over the last few decades. The green represents the ozone and is about 300 Dobson units. The ozone layer had the opportunity to repair itself during the COVID-19 lockdown, as human activity was minimal. You can follow the link at the bottom of the slide to watch more videos and access more information about the ozone layer. Our next lesson will focus on how the atmosphere is heated.